Hi, I am Mustafa. So in this tutorial, we are going to cover hypothesis testing with some examples. So what is hypothesis testing and why hypothesis testing? Hypothesis testing is a critical tool in inferential statistics for determining what the value of a population parameter could be. So why hypothesis testing? Often we draw conclusions based on sample data analysis, and these conclusions are based on the hypothesis we have made. So statistical hypothesis testing reflects the scientific method adapted to the setting of research involving data analysis. In this framework, a researcher makes a precise statement about the population of interest, then aims to falsify the statement. In statistical hypothesis testing, the statement in question is the null hypothesis. So if we reject the null hypothesis, we have falsified. So we have different, like, we have another apart from the null hypothesis, we have an alternative hypothesis. So according to the scientific method, falsifying a hypothesis should require an overwhelming amount of evidence against it. If the data we observe are ambiguous or are not only weakly contradictory to the null hypothesis, we do not reject the null hypothesis. So basically, hypothesis testing has two attributes. We have the null hypothesis H0 and the alternative hypothesis HA. And the test statistic is expressed as this. We have best estimate minus the hypothesized estimate over the standard error of the estimate. So what happens is, like, after computing these tests, we ask ourselves, how likely is it to see this value of the test statistic under the null hypothesis, and we compute some probability value, and based on that probability, depending on that probability, we either reject or fail to reject the null hypothesis. So in hypothesis testing are involved two types of errors: type 1 and type 2 errors. What is type 1 errors? A type 1 error occurs when the null hypothesis is true but is incorrectly rejected. A type 2 error occurs when the null hypothesis is not rejected but when it is actually true, when it is actually false. So this is basically hypothesis testing. So let us have some hypothesis testing, some testing there. In this tutorial, we are going to use two types of testing. We have t-test and the z-test. And each of them, like t-test, we have one sample t-test and two sample t-test. Z-test as well, we have one sample z-test and two sample z-test. What is a t-test in a general setting? A t-test is a type of inferential statistic which is used to determine if there is a significant difference between the means of two groups which may be related in certain features. It is mostly used when the data sets, like the set of data recorded as outcome from flipping a coin 100 times, would follow a normal distribution and may have unknown variances. So t-test is used as hypothesis testing tools, which allows testing of an assumption applicable to a population. So t-tests, we have two types of t-tests, as I said, one sample test and two sample tests. Let us start with the one sample test. What is one sample test? One sample t-test determines whether the sample mean is statistically different from a known or hypothesized population mean. The one sample t-test is a parametric test. So let's create some dummy age data for the population of voters in the entire country and a sample of voters in Minnesota, and testing whether the average age of voters in Minnesota differs from the population. So here we have imported some couple of libraries, NumPy, Matplotlib, and so on. So let us just execute this command. So one sample test, we have it here. So let us create those things. So we have seed here, numpy random.seed6. This allows me for my numbers. Anytime I run the command, they will not change anymore. You can put any number you want here. You have just to put one number. So this is like the population age 1 simulation from the Poisson distribution, start.poisson.random.rvc VS, and we have to specify the standard error and the mu and the size and so on. So the population 2 as well, and we have concatenated these two population, and we move on to the minus star. So age 1 and age 2, we have done the same with different parameters here inside the function, and we have concatenated them like as one data. So we have here what we have done here. Let us complete this command, and these last two lines give me the mean of the population age and the mean of the population age in Minnesota. So notice that we used a slightly different combination of distribution to generate the sample data of Minnesota, so we know that the two means are different. So let's now conduct a t-test at a 95% confidence level and see if it correctly rejects the null hypothesis that the sample comes from the same distribution as the population. To conduct a one sample t-test, we can have this, use this function. So start.t-test_one sample, and here the first argument is the minus star ages, the data we have constructed here, this one, and the second one is the population mean. So let us run these commands. We have this is the t-test and this is the p-value. If the p-value is really less than 0.5, so that means we have to reject the null hypothesis. We don't have to accept it. So which is the case here. The p-value is equal to 0.013, something like that, and which is less than 0.5, so we have rejected the null hypothesis. So that means that the sample does not come from the same distribution as the population. So let us move to the next one, the two-sample t-test. What is a two-sample t-test? A two-sample t-test investigates whether the means or proportion of two independent data samples differ from one another. In a two-sample test, the null hypothesis is that the means of both groups are the same, unlike the one in the one-sample test, where we test against a known population parameter. The two-sample test only involves sample means. Here we have difference in population mean. So we are going to test in terms of population mean. Let us conduct a two-sample t-test by passing with the start.t_test_independent. So int, this is like the function for performing the two-sample t-test. So let's generate a sample of voter age data for Wisconsin and test it against the sample we made earlier. So we made a sample earlier with Minnesota. Now let us make a sample with Wisconsin and test to see the two mean. So this is the code that generates that samples, and you see here we have printed the mean, and here we have performing the test. And what we have here is the t-test and the p-value. The p-value is 0.909 something, which is greater than 0.5. So that means that there is 90% chance that we will see the sample data this far apart if the two groups tested are actually identical. So if we were using a 95% confidence level, we would fail to reject the null hypothesis because this value is greater than 0.05. So this is basically about the two sample t-test in a population mean. Now here we have a population parameters. So let us consider this research question. Is there a significant difference between the population proportion of parents of black children and parents of Hispanic children who report that their child has had some swimming lessons? The population, all parents of black children age from 6 to 18, and all parents of Hispanic children age from 6 to 18. This is our population, and now parameter of interest are the proportions, P1 and P2. P1 for the black one and P2 for Hispanic one. So let us set our test. So the null hypothesis assume that these two proportions are equal, like P1 minus P2 is equal to 0, or P1 is equal to P2. And the alternative one is not, like the two proportions are not equal. So this is the data. We have 47 parents of black children with this proportion. 36.8% of parents report that their child has had some swimming lessons, and we have 308 parents of Hispanic children with a proportion of 38.9% of parents report that their child has had some swimming lessons. So this is the data that we are going to simulate with the binomial random variable, the binomial distribution. So the number of parents here of black and the number of the proportion of parents of black here. Here we have the number of parents of Hispanic and the proportion of Hispanic, which is 0.9 if you just round this. So we have simulated these two populations. Let us see it here, and we have it here. So let us perform the test, the two sample t test. So the two sample t test, we are just going to test these two. So let us compute this test. We are going to have as outcome the t-test and the p-value, and based on the p-value we can decide whether we should reject or we should accept the null hypothesis. So here I have gotten some error. I don't know why. I have executed and it worked, but I don't. But just you try by yourself and you'll have the outcome. I had something like this. I have something like this, and this is greater than 0.05. So in this case, we cannot reject the null hypothesis. So that means that the difference in the population proportion are not statistically significant. Now, what happens if, like, we survey much more number of people? Like, if we increase the number of parents of black children and the number of parents of Hispanic children, and then we do the same thing, so we realize that so the test, the outcome here is the here, and in this case the population, the p-value is very small. That means that we have to reject the null hypothesis. That means that, like, when we increase the number of people, when we increase the samples, like the results might be different, because the first case here we have to accept the null hypothesis, but here we have to reject the null hypothesis by the only fact that we have increased the number of people. So this is it. So we have this p-value, so we have to reject really the null hypothesis. So let us move on to the next test, which is the Z-test. So what is a Z-test in a general setting? So a Z-test is a statistical test used to determine whether two population means are different when the variances are known and the sample size is large. The t-test, the test statistic is assumed to have a normal distribution, and nuisance parameters such as standard deviation should be known in order for an accurate Z-test to be performed. So, as I said, in Z-test we have one sample Z-test and two sample Z-test. Let us start with the one sample Z-test. The one sample Z-test is used to test whether the mean of a population is greater than, less than, or not equal to a specific value. So here we have a research question. Let's say a cartwheeling competition was organized for some adults. The data looks like this following. So is the average cartwheel distance for adults more than 8 inches? We don't know now. So let us do the test. Our population is all adults, and our parameters of interest, is mu, the population mean of cartwheel distance. So the null hypothesis said that yes, it's equal to 80 inches, but alternative hypothesis said no, it's greater than. So let us do the test. This is the data, and then we have the mu, the mean and the standard deviation that we could compute from Python. So let us compute this data, and you can see it here. I have this from Python. This is the mean, and this is the standard deviation, and this is the number of participants here, the number of participants, the size. Okay, so let us do the test the test, we have the data, we have to put the data here in this assume statistic module dot stats dot ZTest. In this argument we put the data first, the value, the mean, like this value, and then in this last argument. And when we execute these commands, then we realize that this test, the outcome of this test is this: the statistic test and the p-value. Here the p-value is less than 0.5. So what we have to conclude is, since the p-value is lower than the standard confidence level 0.05, we can reject the null hypothesis that the mean cut-wheel distance for adults is equal to 80 inches. There is no strong evidence in support for the alternative hypothesis that the mean cut-wheel distance is in fact higher than the 80 inches. But all we know is we have just to reject the null hypothesis. So let us move on to the two-sample Z-test. What is two-sample Z-test? Two-sample Z-test is similar to t-test here, where we are checking two independent data groups and deciding whether sample mean of two groups is equal or not. So difference in population mean. Here let us consider this research question. Considering adults in the NANES data, do males have significantly higher men body mass index than we females? We don't know. So let's perform some tests. Our population is adults in the NANES data, and the population parameter of interest is mu1 and mu2, the difference body mass index. And the null hypothesis assumes that these two mu and mu1 are equal, and the alternative hypothesis said no, they are different. So this is basically the data we have, and we can load the data from these command lines that we have here. It will run. It has taken some times. So yeah, we have the data here. So we have the data here, and we have to extract some features and to perform some tests over there. So there is a variable called rear gender, something like that, that we have to extract for females and then for males, and do some tests here. And this is the body mass, body mass index that we have to compute for male and for female. So, and it will give us the number of females in this body mass index, the mean and the standard deviation, as well as we do the same for men. And we perform the test, the statistic test that takes these arguments. You see, this is like for we want to drop all missing values numbers there, so that we will not have some missing values there inside. So this is the outcome of the test. So you see that this is my p-value is very small. Since the p-value is extremely small, we can reject the null hypothesis that the mean body mass index of male is same as that of females. Not that we use alternative two-sided like in the Z-test, because here we are checking for inequality. So we could also plot the histogram to see. So, but this is basically what we have covered in these tutorials about hypothesis testing. So in summary, we have seen what is hypothesis testing, why do we need hypothesis testing, and which kind of hypothesis testing we have used here in this tutorial. We have used the t-test and the z-test. Each of them we have one sample test and two sample tests. So thank you very much for your attention.